So for 10e, more about resistance. Carrying on from what we did last time, we looked at how you put fixed resistors in series together and in parallel, and how the combined resistance changes in the circuit. We did look at an IV characteristic graph for Ohm's law, which looks like this. So for the fixed resistor, if I draw a graph of I current against, or voltage on the X, current on the Y, and I pass current and change the voltage through the fixed resistor, and I measure the current and voltage for different voltages, then it should look like this, a straight line directly proportional according to Ohm's law, V equals IR. Now, moving on to different components, what we need to know now is, what do the IV characteristic graphs look like for these different components? We've got the resistor, the filament and the diode, and then we're going to look at a different graph for the thermistor and the LDR. So moving on to the filament lamp, in this graph number 2, you've got I against V again, and you need to be able to draw this. So if the exam says draw the graph of an IV graph for the filament lamp, you need to be able to draw this. No values required, just the shape and how it changes. They may give you the graph and expect you actually to describe the trend. What's the relationship between voltage and current as you pass current and change voltage in a circuit with a filament lamp? So just quickly explaining and describing this graph. For the first values of increasing voltage, the current increases, and it looks very similar to the IV for the resistor. So you could say that current is directly proportional to voltage for the low voltages in a filament lamp. Now what happens at the end, so as voltage gets past a specific point, current actually starts increasing less by a smaller amount each time, so it's no longer directly proportional. So the graph is curved, and then it reaches a maximum current here, and then it remains constant. So if you keep increasing voltage through a filament lamp, the current will reach a maximum value and it will not increase past that point. So what's happened inside the filament lamp? Well, if you're increasing voltage but current starts to stop increasing by the same amount, and then it reaches a value that it stays constant at, what's happened is the resistance has changed. So the filament lamp resistance changes as voltage gets too high, and the reason that it changes, it actually increases, so it's stopping current, it's stopping more and more current going through. So if I increase the voltage, it won't keep increasing the current. Like this one, if I keep going up with the V, I will keep going up by the same factor. Here, you can't just keep increasing voltage and expect an increase in current. Something happens in the filament that stops that current increasing. So the resistance increases, it stops current at a certain point, and that's due to the collisions inside the filament of the electrons, the protons and themselves, and the collisions are creating and generating heat, and it's creating more resistance as that happens. So it actually stops more and more current going through. It gets harder and harder. So for a filament lamp, it's constant for small values of V, but then the resistance increases, meaning that the current actually reaches a maximum, and then it won't increase anymore, so it's curved. For the diode, on the other hand, so the symbol for the diode is there. A diode, if you look at the graph, in the negative section, all that means is direction has changed. So for all of these graphs, the negative values are just an opposite direction. So in the diode, if you look in the negative direction for voltage, all negative values of voltage have zero current. That means nothing can go through in one direction. So a diode is a component that is there. It's used to only allow current to flow in one direction. So if you're in the negative direction here, no current no matter what. The resistance is so high that no current will flow. You switch the direction, you start increasing voltage in the positive. Slight voltages at the start will not actually create a current yet. It's like an activation voltage before it starts to flow in the correct direction. And then you can see the resistance drops quite dramatically, and the current will increase, not directly proportional, but actually small voltages will give you a very, very large increase in current. So in the right direction, a diode will have very low resistance and a lot of current will flow, but in the other direction, resistance is so high that no current can flow. And that's your third IV characteristic graph for the diode. Finally, the last two. We've got temperature with resistance. How does temperature affect resistance? That's the thermistor. It's a thermal resistor. As temperature increases, we know that resistance decreases. So there's your curve, increasing temperature, decreasing resistance. And finally, lux. Lux is the unit for light intensity, which is an LDR. So how does resistance depend on light intensity? If light intensity increases, then again the resistance decreases. So you have two negative graphs for thermistor and LDR. So this one is the thermistor and this one the light dependent resistor. They're your 1, 2, 3 IV characteristic graphs. You need to be able to draw them, identify them, and describe what's going on in each one. And then these two are your thermistor and your LDR. How does temperature affect resistance? It's negative. How does light intensity measured in lux? How does that affect resistance? It's also negative. Okay?